Hi everyone. I hope you are seeing the recording. Red? Yes?
I don't know whether
Yeah. It says recording, so I think it is recording.
okay.
I will just
The
state.
meeting is getting recorded.
Okay, excellent. Hi, this is a meeting between Gokhale, Prakash and Manoj, and we are missing Prasanthi, who will join, maybe review the record, and we'll go from there. I have a mail sent to all four of the participants with 3 documents, PDF documents. One of the documents is what Manoj has a proposal, which is related, which he can explain. And the second one, what I have is a what you call a integrated GAS, that is ground, air and space based one paper which I have written previously in 23 times, which I presented but was never published. So it is unpublished, even though I shared the information in the what you call the 5G release at Delhi. So that is there. Third one, we had asked Prasanthi to focus on federated learning. And I discussed with Gokhale the paper, what I was thinking, and then we will start first with Manoj, his briefing, and then follow up with what I have, and then finally we'll leave Gokhale to provide some summary. Go ahead, Manoj.
Okay, this the thought process for this project or the original idea for this particular paper is to ensure the reliability of the messages coming through the end user devices, say maybe an IoT device or a networking device or any other system where the clients or the customers will be sending data through an edge device, and the data will be kept on the cloud. It always happens that the reliability and the validity of the message should all be reaching the cloud. So in order to do that, the um, uh, um, existing architectures such as Kafka, RabbitMQ, or syslog messages of collections at the edge devices was not always sufficient. So we need to have a good handshake mechanism between the customer equipment towards the edge, so that the data will be sent, once again I'm repeating, it's reliable, and all the messages that originate on the customer side will be delivered to the cloud, so that the data scientists or the ML or the subsequent process for the downstreams will be effective. So this method is to ensure the handshake between the customers and the edge devices. That handshake is proper. This is in addition to a stack above the TCP stack. So this is all about the motive of this paper.
Thank you, Manoj. Some of the questions I have is, your assumption is this is real time.
That's right.
Okay. Normally, messaging applications between the edge and the cloud, they use some kind of a MQ, and reliability of that is guaranteed by making sure that they are recorded, like in Kafka,
Correct.
so that you can go back and track and use them. So they are not real time. That's the only catch in that. Otherwise, reliability is guaranteed, and there is a sync, offline sync. So there are projects which are there in the open source which have dealt with
But
this. Yeah,
But this is
coming.
this is this is this is between the edge towards the cloud. But
Yeah,
we need to ensure the reliable between. So there are 100 devices, say in a premises, and those are sending data, and that needs to be collected to the cloud. So this is to ensure the reliability between the client systems to the edge, and the aggregator which sends. So typically they don't, the client systems, right, or the customer premises, say you have an industry with lots of sensors, and they are not all the sensors will have the edge connectivity to the cloud premises. There is only one which can aggregate data and sending it to, so there will be a single pipe outside egress towards the egress.
egress. Yeah.
So in order to have the reliability, it is between those devices and to the edge. From the edge, you can always think like Kafka or RabbitMQ or whatever it is. But this is between the edge, sorry, between the end customer equipment towards the edge, Prakash.
Okay,
Uh,
so
yeah, I just wanted to add something. See, end customer to edge might be a last mile type of a connectivity.
Uh-huh.
There could be multiple hops in between, right? So
Mm-hmm.
that is also a slightly complex scenario. And
Okay.
from the edge down, let's say through an aggregation mechanism,
Mm-hmm.
some sort of a buffering mechanism, queuing mechanism, taking it to the cloud,
Mm-hmm.
would be once again a whole series of different type of I don't know, entities or agents coming into in between. So
So
one protocol, does it fit along is what we need to check out.
okay, so this is between like an IP, TCU API, IP stack. So in between the customer premises, say all the IoT sensors, say for example, or any a domain controller, you can say, and to your edge, there can be multiple hops. We just need to have this application which will be running at the domain controller and at the edge. So if the packet is delivered properly or not, yes, I have delivered that packet, so okay, I can continue. So it is, this is kind of an idea where those particular messages are guaranteed delivered.
See, that sort of a guarantee is directly given by TCP/IP. So what more are we doing out there?
No, in case of network connections, you said multiple hops, right? So if one of the hop is missing, so the packet will not be delivered, or if it's broken in a low latency network, say in IoT device, if the pipe from the um, uh, is broken or something, so you have to resend it. So in those kind of scenarios, it might be helpful.
Because you made a mention that you are planning to have a protocol, a series of handshakes sitting
Mhm.
on top of TCP/IP.
Correct.
yeah, so
So that means what you are actually building in additional level of a delay, an additional
Mm.
level of infrastructure, an additional level of an overhead on top
Mhm.
of whatever is TCP/IP is doing. IP is still lightweight better, but the moment you talk about
Correct.
TCP, let's say
Uh-huh.
media comes in, you have got this streaming media protocols, and they are once again using either TCP or IP only.
Correct. No,
Uh,
this is kind of one idea which I got it.
yeah, yeah, got it. So I'm
And
just
yeah, so
yeah.
regarding the protocol level and other things, we can debate and discuss. But this is one idea which I wanted to bring it to the table. And so, say, for example, if 100 information systems are being connecting or will need to send data to to IPTV simultaneously. So we need to ensure the reliability. So my entire goal is to have a reliable connection all throughout in a choppy or a low latency network kind of environments.
okay, so let me come back here. This is something which is worked over years.
Okay.
And anything if you do at the session layer, there used to be session description protocol SDP. And there are commands which are used for all the devices that use at the session level. Because if it is a real time, it has to be at the session level. If there is anything dropped, we have to resend. And
Okay.
those are the protocol at the SDP. They used to be called SDP. They have been changed as of my knowledge. I just missed that what the protocol name is now. But Cisco, all these people use streaming.
Mhm.
And generally you stream the data these days. You
And
know,
RTSP protocol is there for
yeah,
streaming.
real time. Yeah.
Yeah,
So
real.
all those reservation protocol and there are some other protocols. They were all there, but all of them have been relegated. People want at a lowest level, which is MQ, message queuing,
Okay.
and that's the preferred way. And then there is another thing. There is a offline online sync. So if you go to Qubridge, take a project, look at Qubridge, Qubedge, Qubridge.
Mm-hmm.
Qubridge has got all the things that you are stating, okay? And they have versions of it. I have worked on it, but somehow I dropped out of it after seeing that Edge is going nowhere with that also.
Okay.
So containerized sync and all that. That is, you can disconnect and still pursue with the local intelligence, and when it connects, you sync with the whatever the state is. So those are mechanisms that have been used, and it's fairly acceptable that uh, that is the reason people go after Kafka. We had done with RabbitMQ also, Gokhale, if you remember,
Yeah,
projects.
I did RabbitMQ. Yeah.
So there are ways to handle, but most importantly at this stage, based on what I see, your paper looks good and it has content, it is useful. But then will they anybody select that? That is my doubt. So I felt that we need to update it. But if we
Okay.
update it without a purpose, what we are doing, it will cause problem because it will fall through. So my
Sure.
thinking was this: we need to innovate, and at this time, everything is moving to 6G, and 6G itself is not moving because uh, basic issue is with it is you are trying to do a frequency which is um, difficult to conquer. Okay, without a GPU and without a very fast processing and all that. Even in spite of that, still they are not do anything less than they cannot do anything. Uh, Sub 5 millisecond is what is reachable actually in all with all the uh, practical things they will do. Okay, so whereas they want sub millisecond, and those are really ultra whatever.
Prakash, 1 minute. Prasanthi says that can I call you in 5 minutes?
Oh yeah,
Do we
okay.
have the time?
Yeah, we do have,
Yeah,
okay, we
just
are continuing. We are
uh,
continuing. If you
uh,
are continuing, we are continuing. Let's move.
just send her a link immediately and ask her to join.
Yeah. So the link which is there, I can invite her from here. Just a
Yeah,
second.
yeah.
Meeting info. So what I have is invite people, and you can say Prashanti, Prashanti. What is it? G08 Prashanti dot D08. One sec, let me check.
I do not remember.
No, just a second. I have
Like,
it.
then you just drop it into this WhatsApp only.
Yeah. Okay. So you are saying that just drop it into WhatsApp.
Drop it.
Prashant.
Yeah.
Yeah, one sec. Prashanti, where is? Yeah, it is. Prashanti is here. So let me move this and put Prashanti and get it. Oh, sorry, it will not go that way. Yeah, here it is. Yeah, she already, yeah, I think, please join on this. Please join on this link. Send now at 11:08 p.m. I hope last one. Okay. If she is going to join, then we'll know. Let me see whether she is. Oh, I have. Okay, recording is going on. Hold on. Yeah, Prasanthi, welcome. You can speak. Just say hi.
Did she
Hello?
join?
Hello?
Yeah, she has joined. She has joined. Just a minute. Not in meeting, it says. Oh, okay. She's again in lobby. I thought I let in. Yeah, she's joined. Prashanthi, say hi.
Hi,
Looks like
Prashanthi.
she
She's
joined.
muted.
One sec.
She's
I can
You can
unmute her.
unmute her.
Yes. Hello, sir. Hello.
Welcome.
Hi,
Okay.
okay.
Yeah. Go ahead. Wanted to say something? Yeah. So the first thing is this is being recorded. Part of the record that you missed, you can hear it later. I'll share with you. But we have 4 people here: Gokhale, Manoj, myself, and you. Okay, myself, Prakash, and you, Prashanthi. Okay. The idea is I had sent a mail to all 4 of us with 3 documents. One document presented by Manoj, which is related to low latency, high reliability, massive messaging. I have put it in that terms. And that details we were discussing, and we were arguing that that the paper framework is good, but the concept which is there is based on up to 2020, which is difficult to see that somebody will accept it. Although I don't doubt the credibility, but based on what I know about the cube edge to cloud synchronization through MQ, through Kafka, through RabbitMQ, although they may not be real time, still there is a provision to disconnect and reconnect because reliability is assumed it's not reliable, and therefore you need to resync. And so there are records maintained and they can be synced using the Kafka like with all the guaranteed delivery. Maybe in order, maybe out of order. That's something you can also ask for it and it will do it. But then the guaranteed latency is not there, which is the challenge for anybody. And anything above TCP/IP level, if you do it through session description protocol, reservation protocol, and other protocols which are there from the past 15 years or 20 years, they have not really been able to do anything faster than what can be done based on the 4G and 5G, because they are the ones which are more at the layer 2. And layer 2 protocols seem to, although they require handholding in the sense that you have to ensure that proper bandwidths are there, but anything under layer 2 can achieve that kind of a latency, low latency, which the higher uh, uh, cannot do, because you will have a delay or latency both. Delay in the sense that what is like if you speak on an audio and you have 100 millisecond difference between New York and let's say Bombay, then you are going to get a drag. And voice, it is not acceptable. For video, you can delay and then buffer it, and maybe it is acceptable. But so those are some of the things. The application needs to be, use case needs to be very clear. So what I was thinking is that there are two ways. If we write any paper and if it has to be accepted at a conference level, then it should focus on something new, novel, innovative. Now, what is novel, innovative at the edge is straightforward. We know that 5G, even though people talk about 5G speed, we will increase to terabits and all that, those are fancy things right now, not ready for the prime time. But they can move horizontal in the sense that from what you call as terrestrial to non-terrestrial. So that means we can define edge, which is a mobile, like your drone, UAV, aeroplane or air taxi. It could be a defense application like carrying the proofs or the whatever needs to be carried to the frontier, war frontier or border or whatever, or even for emergency services. So there is a scope. So I have a paper which I wrote and which is I presented in 5G summit when this was in Delhi, 2023 when 5G was released. So that paper I have not published, so it is available, and that focuses mainly on, it's a survey, okay? Actually, it is not a use case. So the survey states that when you do something terrestrial, which is limited to the ground and maybe a few hundred meters, 500 meters or a kilometer max, that is still terrestrial. But then above that, we call it as air or atmosphere. So atmosphere, that can be a place where, which is, so low altitude platform lab, we call it, which goes from maybe kilometers to 10 kilometers, let's say. So all your drones and all can fly in that area. So drone as a client or even as a server piece can be there in the 1 to 10 kilometer range. And 10 kilometer to 17 or 18 kilometers is the place where all your airplane fly. So airplane and air taxi and those kinds of things, where people don't allow any other uh, operation to be done, so that the flight risks are minimized. So people, even though flight paths are there, but they don't allow anything other than that in that area. And that's a restrictive area. Only for authorized IATA or whatever, the International Air Travel Agency, whatever their or the country specific agencies are permitted to work in that area. Then after commercial, there is a space between 18K and 32K kilometer, I mean. So from 18 to 32 kilometer, usually we call it as high altitude platform, HAPs. So HAPs, what you do is you have balloons and all that. So all Google did earlier was to put balloon, and wherever there is emergency, around that they will create the cells and they will have the cell phones being able to use the balloon with the necessary whatever the base stations to be able to create a cell using that and be able to communicate. That's one way that ensures that even if there is no reliability, there is something happening in the ground, like it could be a what you call a tsunami or whatever, they can still handle those from top. So those are HAP. Also, there are some areas in this HAP, that is 18 to 32 kilometer, where generally we launch UAVs, unattended vehicles. They are very similar to, you can say, uh, drones, but the UAVs are much higher thrust, and plus they have to handle the icing which occurs on top of it. So even though you may have some thrust, that thrust which is there, and there are also directional thrusts. It could be to the what do you call? Uh, I don't remember the namings of it, but it's called vertical and horizontal, and then motionally it can go forward, backward. So there are some uh, uh, terms which I'm forgetting right now, but you have to use those terminology to move the UAVs, and they have to be automated in the sense they have to find their own bearing and being able to do everything. So they do have their own point of reference which they use. Now they can be stable, they can be at a given place, or they can be repositioned, and that's one area. Now, so HAP is a place, high altitude platform, where we can peg our edge proxy device, which Manoj was trying to describe. If we have an edge proxy device on that, then that can not only interact with the fleet, which is either a commercial fleet at the lower end, or it can also work with LEO. LEO is a low Earth orbit. Low Earth orbit ranges beyond 32 kilometers, but usually it goes. Normally, you don't do 32. You at least go 150 plus. So I would say 32 plus 150, 170. So maybe 172 you can say. So at 172 kilometer is the minimum, and it can go up to 170, 150 to probably you can go up to 900 or 1000, and anything beyond 1000 kilometer usually you associate with medium Earth orbit. So satellite communication is more based on bent pipe, they call it. Their protocols are bent pipe. That means what? They are at the what you call line of sight, and it is the medium. Medium is usually what happens is you have a medium of uh, it's called free space optics. Normally, when we do communication in the ground, we do use optical communication. So, radio communication, whatever you get, that is the packets, radio packets, they are again stacked and converted to what you call uh, IP level, and then either that or they are converted into Ethernet packets. And if you do Ethernet, then the question is how do you do Ethernet over the optics? So there is a I forget what is the protocol. So you convert the optical to Ethernet and send it over the optics. It's called CPRI, sorry, Common Public Radio Interface. And the later one is called eCPRI, which is extended and Ethernet, so that you can either CPRI or eCPRI is what you use the protocol to send through optical the radio waves. So radio is converted to Ethernet or eCPRI, Common Public Radio Interface, and use that protocol to get it across the optics. And the cost of laying optics is was the issue. Both the China Mobile and India struggled. Ultimately, there are enough uh, points where optics are available, optical network is available, and so there are some limitations. Even there are some. I don't want to get in detail, but simply remember the S, the simpler band, S band, C band, and L band are the bands. They are based on the nanometers or Armstrongs, they call it, 50 nanometer or whatever. Those are the ranges, 800 nanometer. And when you convert into uh, wavelengths, because usually opticals we do through wavelengths, not through frequency, whereas the radio frequency we treat in terms of frequency. So when I say we have a example 4G, we had a bandwidth of 5 megahertz with a carrier being the carrier is always higher, FC and uh, FC plus whatever plus minus, that is a band. So you can have plus minus band. So if I am running a carrier at let's say 900 megahertz, then 900 megahertz plus minus whatever the, if it is 5 megahertz, then it will be 900 and minus 5 and then 900 plus 5. So earlier people used to do at 900 as the carrier, then it moved on to 1800, and then it moved on to 2.2, that is the where the Wi-Fi right now is there, almost there, near close by, then 3.2. So currently 3.3 is the most popular for the 5G. 4G, it was in the 2, and 5G has moved to, they tried to move it to what you call millimeter wave, which is in the uh, 2018 to 28 gigahertz, and in the 5G the bands were changed to 20 megahertz minimum, and in the 6G they are moved to 100 megahertz band. But the frequency range, some people want to still toy with the idea of terahertz and terahertz, megahertz to terahertz they are talking. That's a dream pipe. At this time, at least, I don't see anything that can make that happen in the even in the 6G time frame. More likely, they will come to, there is the first range which was sub 6 gigahertz called FR1, and the 5G went into FR2, failed, miserably failed, and in the they are coming back to 6 to 8 gigahertz, and in fact more than that, because now we are also adding non-terrestrial to non-terrestrial. Non-terrestrial means both in the air as well as in the space. That non-terrestrial portion, usually the uplink and downlinks were different. That means you have an uplink of which is at the higher level, and the downlink is at the lower level for whatever reason I don't remember, but it is something like that. You may have 12 gigahertz uplink, downlink and a 10 gigahertz downlink. So there are some challenges. I don't know exactly what, I don't remember now, but you can remember that there is a difference. There are two bands in which they operate, and that is what the satellite communication, and it's a bent pipe in the sense that if you have a satellite which is in the let's put it, satellite can be three types. Geo is geosynchronous at 36,000 kilometers, no, yeah, 36,000, yeah, and in between kilometers, which is in the 900 kilometer range from 150 kilometer, that is the one which is LEO, low Earth orbit. Low Earth orbit does not cover all the spaces. It only is covering more closer to uh, equator, like we are above the equator, that is India is above the equator, and the others like US is above the, I don't know, whatever it is, tropical or Capricorn or tropic of whatever that above that. So each one has their formula. So you do a satellite cluster of them, usually 3, 5, 8, 10, many, usually 40, 50. So for a cluster of Leo, which is followed by Web, what is that? Web, I forget the name of the company, which is more to do with Airtel in India. And
OneWeb? Is it OneWeb?
OneWeb, yeah, OneWeb. OneWeb, I think that is the one, Elon's, right?
Oh, that is
No,
Elon's
UK,
is,
UK company.
yeah, it is Europe one.
Uh,
Yeah. Utilisat or something.
Europe, yeah, yeah. No, Intelsat is the oldest one.
No, no, Utilisat. You
That
Utilisat. You said. Utilisat.
you
Yes.
said. So OneWeb is the one I think which is participating along with Airtel, and obviously when participating means they had a stake in it. It's a UK company, I believe, and then now what has happened is Geo has also connected with them, but they are Geo operates in the uh, MEO, that is MEO, median Earth orbit. Median Earth orbit generally goes between 1,000 and maybe 20,000, 30,000 kinds of things. So wherever, that depends on how many satellite they have, and how they can cover the Indian Asian continent. So the at least one satellite will be in the region, while they keep rotating, revolving around the globe, and there will be more horizontal revolution. So horizontal means along the equator, circular, and one maybe at 45-degree to be another 45. So they only keep covering they don't go to the poles. They don't cover the poles. Polar region and all, if you want to cover, you have to go with the geo. And MEO is something which is in between, which can cover a little bit more than a particular nation. It can go to maybe Asia, maybe just between Africa and India, and those kinds of things. So that becomes the aggregator for the LEO, and then LEO interacts with the aeroplanes and the UAVs and all. So the use case is important for us. So what we are, at least my take is that I have a paper, you have a paper. Both of us can work together. Now, we also need something to glue together. When you work with edge and edge aggregation, edge device, and so question is, what is client? Client can be, as you said, inside the airplane, it can be a mobile phone, right? Now, is it going to talk to the satellite, or is it going to talk to the device in between? All depends on the latency, right? So that means latency, the closer the devices with the edge can deal with maybe the satellite, and satellite can deal with the ground station. So whole uh, slew of things can be managed. So our assumption is, based on what I am telling you all this, I am trying to position that we have a edge device or edge proxy, what you call. What Manoj calls a edge proxy is nothing but a edge aggregator or a device,
Mhm.
which like you do in your modem like thing on a D2D. D2D means direct device to device. So
Correct.
if you go with the Elon Musk's concept of uh, D2D, he's saying that, hey, I can connect you from satellite directly. You don't need anything else.
Yeah.
Correct?
Correct.
So that is device to device. So that means the device you have, which is a satellite device, and with that you can talk to anybody using bouncing from the satellite.
Correct.
And that satellite is where? That is in the geo, LEO, whatever, right? But that means from airplane you can carry a device that can talk to a LEO satellite, and you can get back device to device direct. Or it can be also be streaming, like you can get the streaming news within the airplane flight by connecting to that LEO.
Correct.
So those things, and that LEO can then deal with the ground station, and it can provide all the information that is necessary, which may be running behind, but it may not be visible for a video and news and all that, right? So that's one of the things. But in our case, what we want to do is we are focusing on a air taxi or a commercial or a not commercial, non, let's say military, not military. What should I call? I don't know the term, but a defense carrying a defense a C-30 plan, which you call in India, I don't know, C-300 or something, which is nothing but which carries all the emergency food item. It can carry all the guns. It can carry all. So that is not just commercial. It is more a defense. So you can have a kind of, I just keep it commercial because easy to hide whatever is there behind. So let's call it, we have a commercial air taxi services, and that needs a constant monitoring, and that monitoring should have good capability in terms of ability to talk to a low Earth orbit, and also it can, if possible, directly talk to some of the devices which are in the uh, what do you call lower range.
Mhm.
It could be even with the terrestrial. So three positions we are burying our devices. Let's say one on the UAV, one on the airplane, and one in the LEO. So those are
Okay.
the three pieces where
Three,
we need to connect these three.
three
And
hops.
what do we do? Question is, what are we going to do? So we claim that we want to monitor the flight. There are many flights running, and we don't want to really disclose what is what. This is air taxi being regulated through a LEO satellite, and that may have information from wherever it brings. We don't care at this time because all our clients are sitting within the flights.
Okay.
And so there are many client devices which are trying to connect and get exchange information, or they are being controlled. So there is a signal and a control and a monitoring, telemetry, all that aspects will be between that flight with all the devices. It could be upstream, it could be downstream. Downstream, it could be some video being streamed, right? So that they can watch something and they can observe something, those kinds of things. So that they can observe that who are their predecessors or who are there. So if a flight, a platoon of them is going and they are trying to do something, they can coordinate. But they can coordinate through what? The question is, it cannot go and coordinate with the terrestrial because they are at a higher height and they need something which is at a higher than them, and that is where the role of a satellite comes in. So LEO is the key, which is trying to work with the air taxis, and which in turn is protecting itself from being attacked by, let's say, enemy UAVs kind of thing. Or it could be our friendly UAV, which is trying to manage. So we have to look at this because air taxis have to go within 10 to 18,000 kilometers. Then 18,000 to uh, uh, 32,000 is where your UAVs are there. And anything above 150k kilometers, which is where the LEO is there. And now LEO is also in its own, there will be multiple satellite, right? It is a cluster of satellites which move around, maybe 30, 40s, but one will be available close to the place where we are trying to monitor the flights. Okay. Now this could be at the border, it could be anywhere, but it is in the range, and this does not have to be depending on GPS. It can be any country's uh, lat long provider, GPS provider, like it could be Gagan, right? So the idea behind this is we just focus on India and said this is applicable and this may be applicable to other places, kind of thing. In India, we'll be able to collect the data or at least refer the data which we can pull out. So that's the thinking. Now, what do we do with that? There is a requirement for hardware, which you already have. I think Manoj has experience on that. A simple modem will do that. But the question will come, what protocol are we using to connect? For the simple, it is over the, what do you call, free space optics, and it is line of sight. And in the LEO to the airplane or UAV, line of sight makes sense because there is no way you are going to get a lot of any disturbance. The only difference comes when it comes to downstream, that is from flight to the ground. If you have anything to do with that, that is why we want to see that it is it's called what do you call, uh, I don't want to call it cloud native. I want to call it uh, what do you call, satellite native. Okay.
Mm.
So like we can do a ground networking graph, one node to another node to another node to another node, we can think of that as a satellite native. So we can call Leo native, and that can deal with MEO, that is their problem, multiple region. But Leo to the UAVs, which are trying to either protect or disrupt. So you can have enemy, you can have those kinds of, we have friendly UAVs and what do you call, unfriendly UAV, you can call it. And those with satellite moving, with UAV moving are stable. Gokhale says that UAV generally are position. So maybe that may be right. I'm not sure about that. I'll have to confirm. But my the cluster, what do you call? If you heard about swarming, swarming is an application where a bunch of UAVs go together and then attack the enemy line at the border. So they figure out what is going on and they coordinate between themselves. So yeah, they move. So UAVs are not necessarily stable. They can be moving, like they may be protecting the aircraft which we are trying to fly. So scenario description somebody has to write down, and then we have to draw a architecture. What are the elements, and then we have to do the survey paper. What I have has got enough information, but it doesn't get into the nitty gritty detail which we may have to get. So then what I have done is I have added a 3GPP paper. Third paper which I sent, it has relation with it's called ICAS, Integrated Communication and Signaling. So what happens is that is something which is interesting. If you go through that 5G, no 6G paper, I believe, or it's a yeah, I think it is related to 5G advanced, or it could be pre 6G. What it has got is it shows
Uh,
two objects. Yeah,
ICAS is about sensing, Prakash. That S is sensing, not signaling.
yeah. So,
Yeah.
since
So that's the reason why it has got
no,
a lot of bearing with
one second. Communication is also there.
correct
Integrated communication.
communication and sensing.
Yeah. So ICAS is related to integrated, and so the paper which I have attached with that, that gives you a diagram 4.1 and 4.2. Review that diagram. Those diagrams show two objects. So what they are saying, you can have same transmit and same equipment to do transmit and receive. You can have separate transmitter, you can have separate receiver, and they can track the objects. So a sending device may not be same as the receiving device, etc., etc. So read that paper 4.1 and 4.2. That we can apply actually to our paper. So what happens when you have a connection? When you have a connection, you establish a channel. And when you establish a channel, then the question comes to if it is going to be based on 5G, what cell they are in. So if you are going to have a base station with cell and all that, then the question is, if you are going to use satellite, how do you deal with these cells? Which cell covers what satellite? Is it going to be that way, or we have to invent a new protocol? So we will have to do some study, but it will not take a long time to crack because we already have two papers. It's just the third one we are trying to integrate into it. So we need a use case description by somebody, then followed by architectural diagram. We can pull out of these 3-4 diagrams we have within the papers what we have right now, and then we can adopt it. And then once we have the architecture, then the question, what are the protocols and how AI/ML will help us in federated learning from the various nodes. It's based on node or it is based on cluster. So is a satellite cluster separate? Is there a swarm or a UAV friendly cluster versus non-friendly or don't care clusters? And do we have a flight cluster? So now we have three clusters, and within these three clusters there are many nodes, and we have to only describe. We can do peer-to-peer to start with, which is the easiest one, and afterward we can hub and spoke types of we can make depending on uh, the the layer where we make it as the uh, edge proxy. So if you are going to put a UAV as edge proxy, then that's dealing with both the air taxi as well as with the air taxi clients, whatever they may be, and with the Leo as a aggregator to be able to manage all these from top as if it is a satellite native. So we can define our own terms, okay, like there is a cloud native, we can call it satellite native. So all this terminology we'll have to define and properly understand how we are going to apply the software portion, which Prasanthi will give us. she's already working on, I believe, Gokhale has given enough thought to that, I believe. So I'll leave it this, but you got what I want to express. But this will be a total novelty. Yeah, maybe it's not novel to people already who know satellite, but they don't know 5G. And those who know 5G, they don't know satellite. Or those who know this, they don't know the protocol. So there is a lot of elements of innovation, and we can really start with one paper, and that becomes the base, and then we can keep on proliferating into a number of papers. But the first paper will be a marquee in the sense that it will be, we want that to be referred by a lot of people as a go-to. At least it should have a life of at least 3 years to be able to be quoted. And that's, if you do quality, then all of you will be happy, and everybody can go with that for a PhD or whatever, if you want PhD, or if you're just looking for a ability to write few papers. So this is what my thinking is, and I will stop here. I have done way beyond my time, but it is important to understand. So let's ask Prasanthi, are you in a position to talk?
Yes, sir. Yes, sir. I heard the meeting and I understood the point. I still have to go through the theory, the papers that you've sent, and then we can come up with a plan for the paper.
Mhm. Okay, but you are working on the machine learning
I'm wo-
federated
I
learning.
am working on free space communication,
Mhm.
like I told about the project, and I do have ideas about the machine learning algorithms that we can use for the clusters.
Mhm. Good,
So if once we proceed with the work, then we can come up with different algorithms and we can test the efficiency based on that.
fantastic.
Yes.
Gokhale, you have anything? Gokhale, are you there? I hope you didn't go to sleep. Yeah, it's too late, I know. Gokhale, are you there? Gokhale, how do I?
I'm there. I could not, unmute myself. My
No, no problem. No
mobile
problem.
is giving problems.
So shall I,
Yeah.
before the final summary you give before I stop recording?
No, you stop recording. I think we have a fair enough idea as to what we need to do. At least the roadmap is sort of clear. We just first is our use case has to be more clearly defined
Yeah,
with clear objectives, and then let us see what type of technology gaps are available. And whenever you have a technology gap, it's an opportunity to create something. Right.
excellent.
If at all we have got something which can be implemented with existing technology, then it becomes only a pure implementation use case. Rather than that, if at all there is a technology gap, I think we have got a very good opportunity. That's what we need to assess first.
Okay, so everybody should have received a mail from me from Yahoo, I think. Yahoo or pramchan@yahoo.com. All,
The three attachments.
yeah, with 3 attachments.
Yeah,
So,
that be a thing. Yeah.
Manoj, you have seen it, right?
Yes, yes, I have seen it. I saw the email.
Prashanti, did you see it?
Yeah.
Yes, sir. Yes, sir.
She
Okay.
got it, but we'll have
Yeah,
to
okay.
go
No,
through
no,
that.
reading, but you have it. That's more important
Yeah.
for me at least.
Yeah,
So,
one
this
suggestion,
will take.
Prakash. One suggestion, Prakash.
Hmm?
Is it okay if we can
Mhm.
create a WhatsApp group among 4 of us? Because emails
Professor? Yeah, sure. Why not?
and then we can
Yeah,
work
yeah, I
on
understand.
and it's
Sure.
easy to communicate if that's okay with everyone. And we
Yes, I
can
think Prashanti, it's okay, right? We create
Yes,
one.
sir. Definitely. Yes, sir.
Okay. Okay.
Yeah.
So we'll create a group um,
and
with some name. I'll just,
yep, yeah,
yeah,
and then
and then
can exchange the
pro-
ideas and if we have to meet, it's we can also join there and then talk and discuss.
correct. And it doesn't have to be this WebEx. We can do it on the Geo Meet, or we can do in
Google
Google.
Meet.
Yeah, yeah. Google Meet is probably better. Let's see whether we can do that in Google.
All
Okay.
right, all right.
All
I
right.
need
So
thanks,
yeah,
Prakash.
Yeah, everybody is for the late night. This one. Next time we will do it in over the WhatsApp, so everything gets settled properly. Okay. I'm
Exactly.
stopping the recording.
Yeah, sure. I can stay up late and then